All right, I'm doing my chemistry homework. This is what it says. The mass of the average boysenberry is 0.28 ounces. The average Tesla weighs 4,900 pounds. If one were to assemble 1 mole of boysenberries, how many Teslas would you need to have a Tesla pile of the same weight? Part of science and part of knowledge is being able to understand the question. Both of these things are hard and empty. I don't know what that question is. How many Teslas would you need to have? How many Teslas would you need to have a Tesla pile of the same weight? The mass of the average boysenberry is 0.28 ounces. The average Tesla weighs 4,900 pounds. If one were to assemble 1 mole of boysenberries, how many Teslas would you need to have a Tesla pile of the same weight? I think that'd be a negative pile, right? So, boysenberries. BNB, we're gonna call it BNB equals 0.28 ounces. And then we have a Tesla TE that equals 4,900 pounds. Now, if we want to assemble 1 mole of BNB, how many Teslas do we need? That's how much I know. What to do with it? One mole. What is a mole of? What is 1 mole? What is 1 mole? If one were to assemble 1 mole of boysenberries, how many Teslas would you need to have a Tesla pile of the same weight? Of the same weight. Of the same weight. What is a mole? Mole. This is in chapter 3, not even in chapter 2. Yeah, 3. Composition of substances and solutions. Formula, mass, and mole concept. The mole is a mount unit similar to familiar units like pair, dozens, that's gross, etc. It provides a specific measure of the number of atoms of molecules in a sampler of matter. One Latin connotation of the word mole is large mass or bulk. Bulk! Say mole equals bulk. So when we talk about moles, we talk about bulk. So if we're trying to make a bulk of boysenberries, but compared to Teslas, the mole provides a link between an easily measure macroscopic property, bulk mass. We need Avogadro's number. That's right. A mole of substance is the amount of which there are 6.022 times 10 to the 23rd discrete entities, atoms of molecules. This large number is a fundamental constant known as Avogadro number. Unit per mole, per bulk. It's kind of like going to Costco. A convenient rounded version being 6.022 to the 10 to the 33 mole. Okay, so those are moles. Those are apparently moles. All of them, they're moles. The molar mass. We have elements. Now we need to take a look at the examples. Deriving moles from grams for an element. Okay. According to nutritional guidelines from the U.S. Department of Agriculture, the estimated average requirement for dietary potassium is 4.7 grams. What is the estimated average requirement of potassium in moles? The mass of potassium is provided. So we have the mass of boysenberries. We have the mass of boysenberries, and we have a mole. We know the Avogadro's number. Okay. And corresponding amount of potassium in moles is requested. Referring to the periodic table, the atomic mass of potassium is 39.10 atomic mass units, and so its the molar mass is 39.10 grams per mole. So what we have, if they given us though, but it's not in grams, like I have it in ounces, right? Yeah, ounces. So I'd have to first put ounces into grams, or should I put it into pounds? No, I think grams. So I don't have my periodic table, so I'm just gonna go 0.28 ounces to grams on Google. And Google says we have 7.94 rounded grams of boysenberries per mole, question mark. Okay. Going back to it. Given mass of potassium is 4.7, a bit more is 1 to 10. So reasonable ballpark. Estimated the number of would be greater than 1.1. The molar amount of substance may be calculated by dividing its mass, molar mass of K atoms in grams, mass of boysenberries atoms, grams. So this is 7.94 grams divided by molar mass in moles of potassium atoms. So the factor label method supports a mathematical approach since the unit G cancels and answers though. Yeah, so then we have 1 mole. So now we just have to go 4,900 pounds to grams. Oh, that's a lot. So now we have I guess that makes sense, because then we have 1, 2, 3, 4, 5, 603 grams. That is a Tesla. Now we just gotta switch these two. So it would be 1 mole. Mole equals 2,222,603 grams over 7.94 grams. Grams and grams go out because math. Calculator. Oh man, no. 7.94 divided by 2,222,603. All right, we have an exponential number. Equals So I would have to go 1, 2, 3, 4, 5, 6, 7. 8.73 times 10 to the negative 7 moles. Mole. And just like that, we did math. Boom. Math. We did math or science. Something. I don't think it's right.